Okay, today we're going to talk about some properties of ionic compounds. Now, obviously we know that every compound in the world is very different, but the properties that we're going to talk about today are general compounds. We tend to see these more in ionic compounds than not. Now, the first one is a non-negotiable property. It is still a property, but it's also in the definition of an ionic compound. So, that is the fact that an ionic compound is always made up of a metal. Draw a little piece of metal here, we'll say that's sodium, and a non-metal. We'll draw some gas here and say that that's chlorine gas. Ionic compounds must always be made up of a metal and a non-metal. You cannot have an ionic compound if it does not at least have one metal and one non-metal in it. That is essential. Now, when these metals when this metal and non-metal bond, obviously we know that these two compounds come together to form salt or sodium chloride. Now, a lot of the properties that we can see in salts are the general properties that we tend to see in most ionic compounds. First and foremost, salt and most ionic compounds tend to have, very high melting and boiling points. Very high melting and boiling points. Salt's melting point is somewhere around 1400 degrees Fahrenheit. This is not something that you would ever be able to reach in your own kitchen, okay? So ionic compounds generally tend to have very high melting and boiling points. And this is all because of how these two, this metal and this non-metal, bond together. So if we say that gray is for sodium and yellow is for chlorine, I will try my best to draw this structure. It might not be awesome, but it will be functional. We know for a fact that opposites attract and like charges repel. So when these two ions, this metal and this non-metal ion, come together and they bond, they tend to do so in this structure. This is what we call a crystal lattice structure, okay? But obviously, we know that it is three-dimensional. So we got out like this in the background. So if we draw it from there, hopefully it looks 3D. Yeah, mostly, right? So what we see here is this crystal lattice structure, and we call it that because all of these positives and negatives are attracted to each other. All of them. Even if they're not bonded, they're still attracted to each other. And that is the cause of all of these properties that we can see in ionic compounds, okay? Because all of these positives and negatives are attracted to each other, they don't want to be pulled apart. They don't want to be pulled apart. They are attracted to each other, and very strongly. So you get that high melting and high boiling point because it's very difficult to pull these ions away from each other. Another property that we get because of this crystal lattice structure, okay, this is a very important word, I should write it down. This crystal lattice structure is that ionic compounds tend to be very hard, which means that you cannot mold them. It's not like clay. Think about the salts that you pour on your food. You can't pick it up and turn it into a tiny little elephant creature. It's going to stay in a cube form, or you're going to dissolve it in your food, one way or the other. But it is hard. You cannot mold it. It's not malleable. You can't flex it back and forth. However, it is brittle, which means it breaks pretty evenly. If you were to go hit your salt with a hammer, you would make a lot of more tiny salt pieces. Okay, so this is just a general idea of some major ionic properties, and let me know if you have any questions.